Okay, so now what we're looking at is sketching graphs with vertical translations, okay? So because we're translating vertically, that means that we're going to have to put a bit more work into working out the x-intercepts. We've seen this before, how basic transformations. In this case, we're considering the effect of plus c. So this is the part where we're getting our vertical translations. This is where we're getting our function will be translated by c units in the y direction, okay? So this is what we've looked at before. Alright, let's go on and look at an example. Okay, so we're now sketching our graph. Now, I really suggest in this case that we start by ignoring our translations. So let's ignore, we know it's been translated by 1 in the y direction and pi on 2 in the negative x direction. But let's just start by considering what our graph would look like before any translations. So we'd just be looking at the graph of negative 2 sine of x. We know that for this graph the amplitude is 2 and the period is 2 pi. So that means when we divide our scale, the period is 2 pi, so I can divide from 0 to 2 pi into 4 sections. Remember, the easiest way to make sure we get a symmetric looking graph, which is important when we're sketching trig graphs, is to make sure that we've got our scale sorted out. So be careful when you're doing this. Make sure that if you don't have a ruler, like I don't, that you're taking care with your scale to make sure that it's reasonable. If you do have a ruler, then that's even better. We can also have our scale on the y-axis. Now notice my scale is going up to 3 because while the amplitude is just, we just have an amplitude of 2, it's going to be eventually translated up 1 unit. So I'm taking care of that right now. So let's think about what this will look like when I have to sketch this particular function. So if I was just sketching a positive sine graph, so if I was just sketching the graph of sine x, we know that the general shape, we start at the origin, we have a maximum, then we have a minimum. But I'm in this case sketching the graph of negative sine of x. So instead, it's been reflected across the x-axis, so we have a minimum first. We can think about where those points would lie. We start at the origin, we have a minimum, back to the x-axis, then we have a maximum point, back to the x-axis again. If we think about the shape, because we need to be careful about what's going on, so here we've got a shape like so. If I was tracing that going backwards, we can see that our next point we're then going to need to continue up to a maximum, back down to the x-axis, to a minimum, and back to the x-axis again. So that's what I'm going to be sketching in this case. So we continue on. Our maximum point then would be at negative pi on 2, x-intercept at negative pi, minimum at negative 3 pi on 2, x-axis intercept at negative 2 pi. If we were thinking about what this would look like, it would look something like this. Now bear with me because, as you'd be aware, my sketching on a computer is not nearly as good perhaps as my sketching with paper, but we get the basic shape of my graph. Now bear in mind I'm then going to need to translate it 1 unit vertically and pi on 2 units horizontally. Now that we've got some idea of what it looks like, let's get rid of it. We don't need it there for now. And we can look at sketching my actual function. So if I was to take any of those points that I just plotted, let's just call them xy. It could be the point 0, 0. It could be the point pi 0. For each of those points, I'm going to need to move the x value to the left by pi on 2. I'm going to subtract pi on 2. And for each of the y values, I'm going to add on 1. Let's start with the far right point at the x-intercept, where x equals 2 pi. I move it to the left pi on 2, and I move it up 1. Then my next point at 3 pi on 2, I move it to the left pi on 2, and up 1. Then my x-intercept to the left pi on 2, and up 1. The minimum point to the left pi on 2 and up 1. At the origin to the left pi on 2 and up 1. Maximum point left pi on 2 and up 1. X-intercept left pi on 2 and up 1. Minimum left pi on 2 and up 1. Now we don't need to continue because the final point at negative 2 pi, if I move that to the left by pi on 2, I would then be outside of the given domain. If we're looking at what happens here, so if I was sketching this graph, we can see, if I'm sketching it, that we're going to come up. We'll have a potential x-intercept, continue on to the x-axis, coming down, we've got a second x-intercept just here. Our minimum, back up, our third x-intercept happening here, up to our maximum, coming down. Now this is our final point, which means presumably it's going to continue down. Presumably I'll have a fourth x-intercept, and I also need to figure out the value of the end point, where x is equal to 2 pi. So let's start working this out. If I'm looking at solving to find my x-intercepts, we know our x-intercepts occur where y is equal to 0. So I'm solving the equation 1 minus 2 sine of x plus pi over 2 equal to 0. We start by subtracting 1 from each side. I'm trying to solve for x. That will give me negative 1. We can then divide by negative 2. Remember, when I divide a negative by a negative, I get a positive. Our next step then would be that we would consider getting rid of the sine. I'd have to take inverse sine. But that's not that simple. This is where I now need to go back to what we talked about before of how to solve trigonometric equations. So starting with looking at the argument, here I've got x plus pi on 2, but in the domain I've just got x. So I'm going to change this to make it x plus pi on 2. If I'm adding pi on 2 to x, then I need to add pi on 2 to the value on either side. 2 pi plus pi on 2 gives us 5 pi on 2, but I'm just going to call it 2.5 pi. It will make more sense when we look at the unit circle. On the left, if I add pi on 2, it would give me negative 3 pi on 2, but again, I'm just going to call it negative 1.5 pi, so it will make a little bit more sense when we look at our unit circle. So we then need to look at our unit circle because we need to consider what's going on, which quadrants we're interested in. Sine is positive, that means I'm looking at the first and the third quadrant. So let's try to work out these values then. So therefore what I'm going to be getting is x plus pi on 2 is equal to, so if we start at 0 and travel in the anti-clockwise direction, in the positive direction, the first point that I get to will be at pi over 6. I can continue around to pi and then subtract pi on 6 to get my second point. If we consider further, if I was to travel around further again, I would get to 2 pi. Yeah. And then if I was to add on, this point here would be 2 pi plus pi on 2, or 2.5 pi, which we know is within our given domain. That means I have one more solution. I have this solution here, I'm getting there twice. I also have the solution 2 pi plus pi over 6. Okay? Now we think, what happened if I was going in the negative direction, if I was subtracting values? So I subtract, I get to negative pi to start with. To get to this value here, I would have to have negative pi minus pi over 6. If I continued around, I would get to negative 2 pi around here, negative 2 pi, plus pi on 6. Now, is this solution actually going to be within the given domain? Because our domain just goes to negative 1.5, I actually think it won't, because negative 1.5 pi would be located there. But if you're ever not sure, it's always better to put more solutions to start with, and at the end check if they appear in the domain. So even though I know that this final solution is not within the domain, I'm going to leave it there for now, just to show you, if you weren't sure, how you would work this out down the track. Our next step is, of course, to simplify these values. So pi on 6, we get 5 pi on 6. Remember, when we're subtracting, we need a common denominator. This is the same as saying 12 pi plus pi on 6. That will give me 13 pi over 6. Now this is the same as saying negative 6 minus 1 pi, so that gives me negative 7 pi on 6. Negative 12 pi plus pi, that would give me negative 11 pi over 6. Now just to make this easier, let's write pi on 2 instead with a denominator of 6. It will make it easier when I have to subtract this from both sides. To get a denominator of 6, I need to multiply by 3, so it becomes 3 pi over 6. Okay, now I subtract 3 pi on 6 from every solution. Pi minus 3 pi, that gives me negative 2 pi over 6. 5 pi minus 3 pi, that gives me 2 pi over 6. 13 pi minus 3 pi is 10 pi. Negative 7 pi minus 3 is negative 10 pi. Negative 11 pi minus 3 pi is negative 14 pi over 6. Now, we always need to give our answers as exact values and as simplified values wherever possible. This is particularly important in the Tech Free exam. So let's simplify these fractions. We can divide both numerator and denominator by 2 to give us the simplified values that we're looking for. Okay, so we're just simplifying these to see what we can get. Now let's consider, are all of these values within our given domain? Negative pi over 3, yes that is. Pi over 3, yes. 5 pi over 3, that's the same as 1 2/3 of pi, yes that's within the initial domain. This is negative 5 pi on 3 is the same as negative 1 2/3 pi, yes. 7 pi over 6, that's the same as 2 1/3 pi. That's bigger than our initial value of 2 pi. So no, that is not a solution. So we therefore know that what we were doing to start with, we can eliminate those values. But like I said, if you're not sure, put them in just in case. Let's locate these values on our graph then. Negative pi on 3 will be located about here. Pi on 3 we will find here. 5 pi on 3, so that's the same as 1 2/3, it'll be just past 1 1/2. And negative 5 pi on 3 will be just past negative 3 1/2, and that makes sense with the shape that we're going for. We also need to consider, of course, our endpoint. So we've already got one sorted, we know the negative 2 pi value, but we need to just clarify what happens when x is equal to 2 pi. If I substitute this into the equation, we get 2 pi plus pi over 2. Now 2 pi plus pi over 2, that's just the same as what's happening at pi over 2. Remember, when we're doing this, let's think about where pi over 2 is located, or 2 pi plus pi over 2. It's located just here. The sine value is the vertical displacement. At this point, the vertical value, the y-coordinate, is 1. So we're going to get 1 minus 2 times sine of pi on 2 is 1. 1 minus 2 is equal to negative 1. So we know that our endpoint occurs here at negative 1. Next step, we need to join them all together. And again, I'm sorry that mine might not be quite as smooth as yours, given that I'm doing this on a computer screen. But hopefully, you're going to get a shape that's looking somewhat smoother than mine when you're using a pencil rather than a stylus. So it's not looking great, but you get the idea. We'll make sure that our endpoints are drawn as coloured in circles because we were given a given domain. We need to show that the endpoints are included. They must have coloured in circles. We then label all of our key features. So our endpoints are key features. We need to label those. Label both endpoints. What are our other key features? Well, our maximum and minimum values. We've got a minimum occurring here at 0, negative 1. We've got a maximum here at negative pi 3 and another one here at pi and 3. We've also got x-intercepts that are also important features. So our x-intercepts we label also. If we had a different y-intercept rather than the one that was shown, rather than it also being a minimum point, we would have to label that as well. That would also be a key feature. So this is our lovely graph. Now just note that when we're sketching this graph, sometimes the x-values, the x-intercepts might not be so nice, but if that was the case in the tech-free situation, if they weren't involving your exact angle values, you would not be asked to find them, you would not be required to label them, and if it was in tech active, you could of course use your calculator to find those values. Okay, that's all.